The topic for this video is gas laws. The essential questions are: what is the ideal gas law and how do you use it? And what is Dalton's law of partial pressures and how do you use it? Okay, so the ideal gas law comes from combining Boyle's law, Charles' law, and Avogadro's law. And so when we do that, there's Boyle's law over that part is Avogadro's law, and there's Charles' law. And we can combine it just like that. And so all of these make assumptions that pressure's not changing or volume's not changing or temperature or whatever. But when we combine them all, we can use this to determine a variety of changes in a gas. So let's look at a practice problem. A 10-liter rigid tank has 1 mole of oxygen at a temperature of 20 degrees Celsius and a pressure of 575 kilopascals. The oxygen was transferred to a 15-liter tank at a temperature of 35 degrees Celsius. There also was another 0.25 moles of oxygen added. We want the pressure in the new tank. So there's my first volume. There's the moles that go with it. There's the temperature that goes with it, and there's the pressure that goes with it. Now if we go through again, 15 liters is my second volume. My second temperature is 35. My second number of moles is 1.25 because we had 1 mole and we added another 0.25 to that. And we're looking for the pressure. So we've got our formula, our combined gas laws. Okay, so I can plug in P1 times V1 over N, and I need to add 273 to my temperature to make it in Kelvin. And then I have P2 times V2 over N times T, again adding 273. Okay, so what I can do here is cross multiply. So I have 575 times 10 times 1.25 times 308. And when I multiply all that together, I get 2,213,750. I can do the same on the other side. 1 times 293 times P2 times 15. And I get 4,395 times P2. And then I can just divide to get my pressure. And I get 504 kilopascals. So at standard temperature, which is 0 degrees Celsius, and pressure, which is 101.3 kilopascals, 1 mole of gas has a volume of 22.4 liters, which we learned a while back. So if I plug all that in, I get R, which is the gas constant. So when I plug in all those scenarios, I get 8.31 as my R, and that's using the units liters times kilopascals and moles and Kelvin. So then we come up with the ideal gas law out of that using that R. So this time you don't have to have two different sets of information, you just have one. Pressure, volume equals number of moles times the gas constant times temperature. So pressure can be in atmospheres or millimeters mercury. Volume can be in liters only. Number of moles. R is the gas constant and T is the temperature, and it has to be in Kelvin. So I gave you one possible R before. Here's another one, and it's with atmospheres. Okay, so it all depends on which pressure you're using. The first one I gave you was kilopascals. This is atmospheres, or if you're using millimeters of mercury, you would use the 62.4. So you have to look at your units of pressure and decide which R you're going to use. So let's look at a practice problem. What is the volume of 2 moles of hydrogen gas if the pressure is 3 atmospheres and the temperature is 25 Celsius? So I want to divide both sides by P because I want to find the volume. Sorry, it's a little bit off there, but our formula is nRT over P. So my number of moles is 2. My R, if I look at my pressure in the problem, it's in atmospheres, so I need to pick the R that's in atmospheres. And my temperature is 25 plus 273, which is 298 Kelvin. I'm going to divide that by the pressure, which is 3 atmospheres, and I plug all those numbers into my calculator, and all these units are canceling out, and I end up with liters for my unit, and I get 16. Okay, let's look at another one. How many grams of argon gas are in a metal cylinder that has a volume of 12 liters, a temperature of 22.5, and a pressure of 5,500 millimeters of mercury? Okay, so we have our formula. We want to solve for moles first. It's asking how many grams, but if I get moles, I can get to grams. So I'm going to divide both sides by R and T, and so there's my formula that I'm going to use. So I have my pressure is 5,500, my volume is 12, My R, I have to pick the one with millimeters of mercury, so that's 62.4. and my temperature is 295.5 after I've added the 273. So I divide and I get 3.5793 moles, and then I'm going to use molar mass of argon. There's all my units canceling, so it's out of order a little bit. Put 1 mole on the bottom. I'm going to look up argon on the periodic table, and it's 39.9 grams, and I'm going to multiply across the top, and I get 143 grams, and that's my answer. Let's look at another one. A helium balloon contains 1.85 grams of helium at 23 degrees Celsius and a pressure of 1.05 atmospheres. What is the volume of the balloon? Okay, so the first thing I need to do is I can't use the ideal gas law with grams. I have to go to moles. So I'm going to use the molar mass of helium and divide that out, and I get 0.4625 moles, and now I can use the ideal gas law. So I'm trying to find volume, so I'm going to divide by P on both sides to get volume by itself, and there's my formula. So I'm going to use the number of moles I just got. I'm using atmospheres, so I need to use the R that works with atmospheres for pressure. I have 296 for my temperature once I've added my 273, and I divide by the pressure, which is 1.05. So now my units are going to cancel. Okay, so I'm going to end up with liters. I multiply out and divide, and I get 10.7 liters. Okay, the other law we're going to talk about is Dalton's law of partial pressures, and this is pretty easy. It says the total pressure is in a mixture of gases, just like air is a mixture, is the sum of the partial pressure of each gas. So if you have hydrogen over here and helium in the middle, and then you decide to mix them up together and you keep the same pressures, then you can just add their two pressures together. So the total is equal to the first pressure plus the second pressure plus however other many pressures you've got. So for example, the air in a scuba tank contains oxygen at a partial pressure of 58 atmospheres, nitrogen at 108, and helium at 45. What is the total pressure in the tank? All I have to do is add those three together, and I get 171 atmospheres for the total pressure. Okay, a mixture of gases in a cylinder is 20% argon gas and 80% nitrogen gas. If the total pressure in the tank is 1100, what are the partial pressures of each? So I'm going to change my percentage to a decimal, so that becomes 0.80 for nitrogen, and I multiply it by 1100, and that's 880 millimeters. I do the same thing for argon. 0.20 times 1100 is 2200, and if you want to double check, you can add those two together and you'll find that they make 1100 for the total.